Science Alliance. I am Rashida Batra. Today we will start our topic with chemical properties of bases. In the previous video we have discussed about acids and physical properties of base. So if you have not watched the video, the link of the video is in description box. You can watch it. Now let's get a quick revision of physical properties of base. First one is they are soapy in touch and they are bitter in taste. Second is they release OH minus ions when they are added to aqueous solution. And third one was their action on various indicators. Now let's start with chemical properties of bases. First one is action with metals. When base reacts with metals, hydrogen gas is released. Some of the specific reactions here are when zinc reacts with NaOH, it forms Na2ZnO2, which is sodium zincate, and hydrogen gas is released. Second one is tin. When react with NaOH, it forms sodium stenate and hydrogen gas is released. Third one is aluminium. When reacts with NaOH, it forms sodium meta-aluminate and hydrogen gas is released. Next chemical properties of base is action with non-metallic oxide. Oxides of non-metals are acidic in nature. When acid reacts with base, it forms salt and water. First example is when NaOH base reacts with CO2. CO2 is a acidic oxide. When it reacts with NaOH, it forms salt, which is sodium carbonate, and water is formed. Next reaction is when calcium hydroxide reacts with sulfur oxide, sulfur dioxide, it forms calcium sulfide and water is formed. Let's discuss now strong and weak bases. As we know, there are strong and weak acids. Strong acids are those acids which release more number of H plus ion when they are added in water, and weak acids are those acids which release less number of H plus ions when they are added in water. Likewise, there are strong and weak bases. As we know, bases release OH minus ions when they are added in aqueous solution. So, a strong base will release more number of OH minus ions when they are added in aqueous solution, and weak base releases less number of OH minus ion when they are added in aqueous solution. Let's take an example. Potassium hydroxide, when it is added to aqueous solution, it ionizes into K plus and OH minus ions, potassium ion and hydroxide ion. And another example of ammonium hydroxide, when it is added to aqueous solution, it dissociates into ammonium ion and hydroxide ion. Here OH minus ions released are more. It is categorized as strong base. Here OH minus ions are less, so it is categorized as weak base. These strong base and weak base are decided on the basis of degree of dissociation, which we will discuss in class 11. Our next topic is acidity of base. Let's start with definition. It is the number of replaceable hydroxyl ions present in base when dissolved in water or aqueous solution. किसी भी बेस को वाटर या aqueous solution में ऐड करें तो कितने हाइड्रोक्सिल आयंस मतलब OH माइनस आयंस रिप्लेस किए जा सकते हैं, वो क्या कहलाएगी उस बेस की एसिडिटी. फॉर एग्जाम्पल NaOH, इसको जब मैं वाटर में डालूंगी, इट विल रिलीज Na plus and OH minus. Here one OH minus is released, so it is monoacidic base. Second one, again KOH, its acidity is also 1. Here when it is added to aqueous solution, calcium ion is formed and 2 OH minus are released, so it is diacidic base. magnesium hydroxide it's also a diacidic base. When aluminium hydroxide is added to aqueous solution, it forms aluminium ion and 3 OH minus ions are released. It is known as triacidic base. After seeing this, a question might have popped in your mind that what do acids and base have in common, as acids release H plus ions when they are added in aqueous solution and base release OH minus ion when they are added in aqueous solution. So what do they have in common is most of the acids and base have the tendency to conduct electricity, and they have some exception also. Chemistry is full of exceptions, as we know. Now to prove that acids are good conductor of electricity, we will observe an experiment in which I have taken one beaker in which rubber cork is added and 2 iron nails are added, which is connected to a battery, a 6-volt battery, and further it is connected to a bulb and a switch. And in the beaker I have taken dilute HCl. अब जैसे ही मैंने स्विच ऑन किया, यहाँ से करंट पास होगा इस सॉल्यूशन में से एंड बल्ब के पास जैसे जाएगा बल्ब ग्लो करने लगेगा, और यहाँ से ये पता चला है कि जो HCl है वो आयनाइज होकर H प्लस और Cl माइनस में टूट चुका है और इट हेल्प्स इन द ग्लो ऑफ द बल्ब. यहाँ से जो आयंस थे वो बल्ब के पास गए और इट हेल्प्स इन द कंडक्शन ऑफ इलेक्ट्रिसिटी. अब यहाँ पर मैं HCl की जगह अगर H2SO4 लूँ तो भी यहाँ पर बल्ब ग्लो करेगा. अगर इसकी जगह मैं ग्लूकोज लूँ जिसका फॉर्मूला है C6H12O6, अगर HCl की जगह मैं ग्लूकोज का सॉल्यूशन लूँ, यहाँ पर 12 हाइड्रोजन प्रेजेंट है, बट इस केस में यहाँ पर बल्ब ग्लो नहीं करेगा. क्यों नहीं करेगा? ये एक्वस सॉल्यूशन में जाने के बाद कोई भी H प्लस आयंस नहीं देते हैं, जिसकी वजह से इलेक्ट्रिसिटी कंडक्ट नहीं होती है.
नाउ इट इज़ नॉट नेसेसरी कि किसी मॉलिक्यूल में हाइड्रोजन एटम प्रेजेंट है तो वो एक्वस सॉल्यूशन में इलेक्ट्रिसिटी कंडक्ट करेगा. रादर इट इज़ इम्पॉर्टेंट दैट when it is added to aqueous solution it should release H plus ions so that electricity is conducted. अगर आपको कोई डाउट है, कोई कन्फ्यूजन है, तो आप इस वीडियो के कमेंट सेक्शन में जाकर कमेंट करके मुझसे पूछ सकते हैं. आई होप आपको आज का वीडियो अच्छा लगा होगा. लाइक शेयर सब्सक्राइब करना ना भूलें and press the bell icon for more videos. See you all in the next video. Till then, take good care of yourselves and thank you so much.